So, hello everyone, welcome to Maths Magic channel once again. Today, in this video, we will learn different types of centers of a triangle. Okay, here basically we will learn about four types of center. In the ancient mathematics, we can see in ancient mathematics that they have pointed out four different types of centers of a triangle. What are these? These are number one is centroid. Number two is Ortho Centre. Number three is in center. Number four is Circumcenter. Alright, so what is centroid? First I will show using this green board, then using compass the actual figure how to draw these centers. So that things I will show you, but first let me explain the concept, then using this compass, scale, protractor, geometrically I will show you. Okay, so coming to this first, centroid. Centroid is what? Centroid is intersection of three median. Okay, this is intersection of three median of a triangle. Median. Okay, so suppose this is a triangle OMG, right? What is median? Median is the line segment joining the vertex, any of the vertex of the triangle, and the middle point of its opposite side. If you take vertex O, then opposite side will be MG. Its middle point you have taken, and if you join this, then you will get median, right? You will get median. So we join it. Similarly, this middle point and this middle point, join this. So this name is suppose D M S. Okay, so M and same name has come. I will change the name. Name is suppose T. Okay, so join MT. This is another median. Join SG, another median. So this point is centroid. You give C. Okay, this is called the centroid. So centroid is meeting point or the intersection of three median. Okay, this is centroid. Geometrically I will also show you. Just wait for 2 minutes, then I will show. Coming to this Ortho Centre. Okay, now Ortho Centre, you can take the screenshot, okay, of this. I proceed to this Ortho Centre. What is Ortho Centre? Ortho Centre is this is intersection of three perpendicular sorry, orthocenter is intersection of three altitudes. Okay, altitudes. of a triangle. Okay, intersection of altitudes, three altitudes. Suppose then this is another triangle. Okay, name is suppose TOP, top. Okay, so you draw altitudes. So from T vertex you draw altitudes using compass also. This is one altitude, and from this one you draw another altitude on it. Okay, so in this point you may get the altitudes. I'm trying to show inside. Okay, changing this figure a bit so that right now it will be inside the triangle. Just to see it. Then I will tell different types of centroid, but right now trying to show you easily. Then different cases, many things, many conditions are there that I will also try to explain. Okay, so from this point you draw perpendicular. Okay, you will get it this way, and from this point draw this. Yes, and from this point here you draw another. Yes, this angle is 90 degree. Okay, this angle is a 90 perpendicular height, means corresponding to three bases. You will get three different altitude. Area will be half into it. You take this base mtg. Okay, if you take this tg base, so this will be tg. Okay, this base and these altitudes. Okay, suppose this is h1, h2 and h3, so this will be into h1. If you take mg, then half into mg into h2. If you take mt, then half into mt into h3. This way you can find out the area of the triangle. By the way, this point is called, this point is actually called the ortho center. So intersection of three altitude is known as ortho center. Okay, next is in center. We'll discuss about in center. So what is in center? In center is in center in center is in center is intersection of three bisectors of angle, bisector of angle. So suppose this is again another triangle. So angle bisector in this way you have to draw. For this way you have to draw. Okay, and for this way again you have to draw this. So you will see this, at this point they will intersect. Okay, so this point is called the point of this is called the in center. This point is intersection of three angle bisector. Angle bisector means a line which will bisect the angle into different part. This is called the angle, this is called the angle bisector. Okay, so these three are angle bisector, they intersect at this point. So this point is called the in center. Why this in center? Means this point is the center of a triangle, a center of a circle which is just inside the circle, inscribe the triangle. Okay, inside the circle, this point is the center of this circle. That is why it is called in center. Okay, I will also show how to draw the construct the in center of a triangle. Okay, that I will also show you. Now coming to this one, circumcenter. So what is circumcenter? Circumcenter circumcenter is what? Circumcenter is intersection of perpendicular bisectors of sides. Okay, I'm showing you that how to draw this. Okay, next page. Suppose this is a triangle. Okay, you have to take more than half of it, then here and here draw. Again more than half of it, here and here draw, in this way. Okay, again half of it here and there. So in this way you'll get the perpendicular bisector. What is perpendicular bisector? Suppose this is the side, you have to take more than half of it here and here, more than half of it here. At the middle point, this line will intersect the line segment. This is called perpendicular bisector. It's sect into two parts, equal part, that is why bisector, and perpendicular, that is why it is called perpendicular bisector. Okay, so this intersection of three perpendicular bisector is called the circumcircle. Okay, circumcenter. Why do this is called circumcenter? Because if you draw a circle taking this point as center, then you can see this type of one circle you will get, which will be the center of this. All right, so this is called, that is why it is called the circumcenter means circle will be circumscribe the triangle, means outside the triangle, and in center mean the center will be the point will be the center of the inscribed circle. Okay, that is why in center, and this is called circumcenter. Now I will show it uh, in a geometrical construction form. Okay, using this compass and scale. Actual figure I will show you. Okay, have a look. Before showing actual figure, constructing all these things in center and circumcenter, I want to give you one more information about the position of the center. Okay, position of the, yes, you remember this these two, one is this one, this in center and centroid, these two centers always will be inside the triangle. Point number 1 and 3, always inside the triangle. And point number 2 and 4 may be inside the triangle or maybe outside the triangle. Okay, in case of centroid, it may be at the right angle on the at the point of right angle, and in case of circumcenter it may be on the hypotenuse. Okay, so all these cases are very interesting, so that things we will discuss right now. Okay, using compass, real figure I will show you. I repeat these two things, centroid and in center always will be inside the triangle, understand, and this orthocenter and circumcenter, this may be inside the triangle, may be outside the triangle. Okay, one more things about this in center and circumcenter. In center, suppose this is in center is equidistance from each side, in center you can see the circle. So these all are radius, okay, and perpendicular distance between the incenter and the side, okay. So this is perpendicular on the side, on each side, so that is why this is distance. So incenter is equidistance from each side, okay. And case of circumcenter, circumcenter is center which is outside the center of circumscribed circle, that means outside the triangle. So it is equidistance from each vertex. So circumcenter center is equidistance from each vertex, okay. So circumcenter is, this is in center and this is circumcenter. So circumcenter is equidistance from each vertex and incenter is equidistance from each side. So this question comes in MCQ in competitive exam. So you will choose the option correctly. Okay. Now time to represent all these things practically. That mean in geometrical construction form. Okay. So let's start. So now I'll show you how to draw in center first. Centroid and all these things you can also. I'll show first how to draw in center. Okay, what in center? How to draw in center? In center. That's it. Okay. So I'm taking three sides. One triangle I'm taking. Suppose right angle triangle I'm taking. Random scale. Acute triangle I'm taking. Okay. Sure. Yes. So as I told that in center mean bisector of which one? Angle. Bisector of angle. So we'll bisect the angle. Then take half of it, draw it here. You can extend this, so figure will be clearly visible then outside the triangle. Okay, this is better. Then there will be means no problem inside the triangle. Very easily you can see the in center. Okay, next this one we'll join later on. Let me first draw the bisector. Yes, I will extend it and draw outside it. Okay, outside the triangle, these two arc I can put it here and draw. So fantastic representation of all these things using this digital platform. This is very nice. So these two angles done, then the third angle. Yes. This measure, any measure you can take, no problem. Draw it. Yes. Again put it here. Extend it. That's all. Then join. One. to see perfectly. This is the in center. Okay, now we'll draw inscribed circle inside the triangle. Then another process is there. What you have to do, black color I'm using, you have to take the compass. Okay, you put it here. Then what you do, very clearly you see this. Then you drop one perpendicular line on this side. Okay, see very carefully. Black color, yes. You draw an arc in this way. Then we'll draw perpendicular. Okay, perpendicular on this side from this in center. Yes, I can draw the arc. You cannot understand, that is why just wait. In different way I will draw it so that it will be clearly visible. Right, I think now it will be clearly visible. Yes, so any measure you take and draw an arc which will divide these two sides, this side. Okay, any other side you can also take and you can draw this one. Okay, so what we are drawing right now, we are drawing a perpendicular line from this in center to any of the side. Okay, perpendicular from the in center to any of the side. This is the process. Yes, and then from here now you remove it and join. Got it. Now what to do, you can see this position, this measurement. Okay, we'll take this, we'll put our compass in this position and we'll take this measure. You can see this black part. Yes, this black part. Yes, this one. Fixed it and rotate and see this. Maybe there is little bit problem in the construction because you can see very means many points are there and these bullets is not sharp. That is why problem is coming. But you if you use the compass in your copy, then clearly you can see the point will what that touch the every sides. Okay, so you will get the actual in center of this. Here two side it have touch, but if you practice in copy, then this part will also touch. Okay, this point you be very clear that from in center you draw this way one perpendicular, right? And you have to take this measure and then you have to draw. You will see this will be the center of the in center and each side will definitely means touch the circle is touch each of the side. Okay, so this is geometrical representation of in center. Now we'll show that if the circumcenter, I will try to show you next circumcenter. So again we are taking one triangle, this time obtuse triangle I will take. Okay, see it will be inside or outside. Put the compass. So circumcenter means you know this perpendicular bisector you have to draw. So take more than half of it taken. So we'll rotate it. Perpendicular bisector. Okay, problem is coming for this. You can see the needle we cannot put clearly. This bubble, you see this a thick bubble bullet is coming, but not the sharp bullet. Okay, that is why little bit problem is coming. So this is for this, which one, join perpendicular bisector of this side. Similarly, we'll draw 3 perpendicular bisector. I'm just pausing the video. For the third one, we will draw perpendicular bisector. You have to take more than half of it. Okay, then you have to draw here, and another is here, this side, and put it here and draw. Red color I am using. Okay, another from here also. This side. So step by step you have to follow, otherwise you will be confused that what happened, right? So you see this point is really meeting each other. 3 perpendicular bisector meeting each other. Okay, now this is called the circumcenter. Now let's see a circle will be formed or not. Okay, so you can see this. I have taken this one, this circumcenter. I will try to draw one circle which will supposed to touch the vertices. Let's see, in the center we have seen a minor mistake. I told this is little bit difficult, but in copy the process, if you know, that you can very easily draw this in your copy. So let's see it will touch the vertex or not. Okay, here you go. So start to draw the circle. Yes, 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 yes. Oh my god, that's really touching each and every vertices. Fantastic. So that is why this point is called the circumcenter. Okay, so you can see this in this video, that in this construction, that circumcenter is now outside the triangle. This is not inside the triangle. Okay, so if you take obtuse triangle, then it will be outside the triangle. If you take right angle triangle, in that case you will see the circumcenter is coming here on hypotenuse, and triangle will be just like this way. Okay, if you take in center for right angle, then you will see in center will be this point. In center will be where? In that case, in center will be, yes, extremely sorry, a little bit mistake. In case of in center, point will be here. You go for it. In center bisector this, bisector this, bisector this. Okay, not in center. I told that in center will be always inside. I told your ortho center and yes, ortho center and circumcenter. Yes, these two. So in center always will be inside. So you can see this for circumcenter outside. If you take obtuse, if you take right angle, then what will be circumcenter? Circumcenter will be where? Circumcenter will be, yes, you have to draw perpendicular bisector. That means this way you will get it. Yes, again other will be where this is perpendicular and this is also perpendicular, right? So in case of perpendicular bisector will be here, another perpendicular bisector here. Yes, so in case of right angle, your circumcenter will be where? On the hypotenuse. So in case of right angle, right triangle, hypotenuse will be on hypotenuse. Okay, right triangle, circumcenter will be on where? On the hypotenuse. So this circumcenter will be on the hypotenuse. Circumcenter will be on the hypotenuse if the angle is right angle triangle. Now for orthocenter, if you take this right triangle, what will be the position of the ortho? In case of obtuse triangle, both orthocenter and circumcenter will be outside, but in right triangle, circumcenter will be on hypotenuse. And if you draw the perpendicular, means orthocenter means three perpendicular, so this is perpendicular already, and this is another, so this is okay circumcenter. And you see these three perpendicular, three altitudes, this is altitude, this is altitude, this is altitude, meet where? At this point, at right angle. Okay, if the point A point is right angle, then at A point they will meet, and in that case you will get this orthocenter where? At the point A, 90 degree. Okay, so these are the cases. Circumcenter will be inside, in case of obtuse it will be outside, in case of right angle it will be on the hypotenuse, and in case of the right triangle, center orthocenter will be out at the point A, 90 degree, orthocenter at the point A. But in obtuse triangle, both the center ortho and circum will be outside, but in the case of 90 degree, circumcenter will be where? On hypotenuse, and this ortho will be at the 90 degree angle. Okay, so these are the cases. I hope I've tried to explain you. You will practice definitely using your compass and protractor. Then you can see the actual figure of this type of circumcenter and incenter. Incenter you will be very careful. In maximum cases, you cannot draw this inscribed circle, means circle inside the triangle. Outside circle is okay, but inside circle, inscribed circle is little bit problematic. You may have some errors, so be careful. Okay, I hope you have enjoyed today's class. Thank you so much.